September 27, 1942, 11:47 a.m., Richmond, California. Henry Kaiser stood on the deck of the SS Robert E. Peary, watching the American flag snap in the wind above the wheelhouse. 4 days, 15 hours, and 29 minutes. That's how long it had taken to build an entire cargo ship from keel to launch. The welders were still cleaning their torches when the crew began loading supplies. Every expert in Washington had said it was impossible. The Maritime Commission had laughed him out of their office. The Navy called his design floating coffins. German U-boat commanders called them easy targets. But in 72 hours, this ugly, boxy vessel would be crossing the Pacific with 10,000 tons of ammunition, jeeps and canned food, heading toward British forces in North Africa. Before we continue with Henry Kaiser's incredible story, we need your help to keep these forgotten heroes alive. If you're already hooked by what you're hearing, hit that like button right now. It tells YouTube to share this with more people who care about real history. Subscribe to this channel so you never miss another story of courage and innovation from World War II. And here's something we love. Drop a comment below and tell us where you're watching from. Your country, your city. We have viewers from Buenos Aires to Berlin, from Manila to Montreal. Are you veteran? Did your grandfather serve? Do you have a connection to this war? We want to hear from you. Now back to Richmond, California, where Henry Kaiser was about to revolutionize naval construction forever. The problem wasn't the ships themselves. America had shipyards. The problem wasn't the steel. American foundries could produce enough. The problem was time. German U-boats were sinking Allied cargo vessels faster than traditional shipyards could replace them. In 1941 alone, 432 Allied ships went to the bottom of the Atlantic. That was 1 million tons of supplies, weapons, food and fuel that never reached Britain. At the current construction rate of 140 days per ship, the Allies would lose the war before Christmas 1943. Henry Kaiser was 59 years old, 5'8", with silver hair and the permanent squint of a man who'd spent 40 years reading construction blueprints in bad light. He'd never built a ship in his life. He'd built highways, dams and bridges, the Grand Coulee Dam, the Hoover Dam, the Oakland-San Francisco Bay Bridge. His specialty was doing the impossible on a deadline nobody else could meet. He grew up in Sprout Brook, New York, population 287. His father was a German immigrant shoemaker who drank away every paycheck. Henry dropped out of school at 13 to work in a dry goods store for $5 a week. He photographed weddings on weekends. He sold those photos door to door. By 16, he owned his own photography studio in Lake Placid. By 22, he was selling sand and gravel in Spokane, Washington. By 30, he owned a paving company. By 40, he was building dams that newspapers called engineering miracles. Everything Kaiser built, he built fast. When the Boulder Dam project opened for bids in 1931, the government estimate was 7 years. Kaiser promised 5. The other contractors laughed. Kaiser formed a consortium called 6 companies, hired 500 men, ran 3 shifts around the clock, and delivered in 4 years, 11 months. When asked how he did it, Kaiser said, "Find out what can't be done and do it differently." In June 1940, Kaiser read a small item in the San Francisco Chronicle. Britain had lost 140 cargo ships in 3 months. Winston Churchill sent a desperate cable to President Roosevelt. "We need ships or we die." The British shipyards were already running at maximum capacity. American yards were building at the traditional pace, riveting each seam by hand, building each vessel one at a time, launching 3 or 4 ships per month from any single facility. Kaiser did the math in his head. At current loss rates, Germany would starve Britain into surrender by mid-1942. The only solution was to build ships faster than U-boats could sink them, not 10% faster, not 50% faster, 10 times faster. He called the Maritime Commission in Washington the next morning. They told him he was insane. He called them every day for 6 weeks. Finally, they agreed to a meeting. The conference room in the Maritime Commission building smelled like cigar smoke and old wood polish. 12 men in Navy uniforms and dark suits sat around a mahogany table looking at Kaiser like he was selling them the Brooklyn Bridge. Admiral Howard Vickery, Vice Chairman of the Maritime Commission, did most of the talking. He had 3 gold stripes on his sleeve and 37 years of shipbuilding experience. Kaiser had 0. Mr. Kaiser, do you know how long it takes to train a ship riveter? No, sir. 2 years minimum. Do you know how many experienced shipwrights are currently available in the United States? No, sir. Approximately 17 Zuzuzaras. Do you know how many we would need to build ships at the rate you're proposing? More than we have. Exactly. So this conversation is over. Kaiser opened his briefcase and pulled out a blueprint. What if we didn't rivet them? Vickery leaned back in his chair. Cargo ships have been riveted since the invention of iron hulls. Welding is faster, yes, but it's weaker. The seams crack under stress. The whole ship can break apart in rough seas. We've tested welded ships, they fail. You tested the wrong welds. The room went silent. Vickery's jaw tightened. Are you suggesting the United States Navy doesn't know how to weld? I'm suggesting you're using techniques designed for battleships. Different metal, different stress loads. A cargo ship doesn't need armor plate seams. It needs speed and volume. I can weld an entire hull in 1/3 the time it takes to rivet, and I can train a welder in 6 weeks. 6 weeks. 6 weeks. Mr. Kaiser, this commission has reviewed proposals from Bethlehem Steel, Newport News Shipbuilding, and Bath Iron Works. These are companies with decades of experience and thousands of trained workers. You're telling me you can outbuild all of them, combined with untrained labor and an untested welding technique? Yes, sir. Vickery stood up. The meeting was over. But as Kaiser walked toward the door, Vickery said, "One prototype, British design, Maritime Commission specifications. If you can build it in under 6 months without it sinking, we'll talk about a contract. Fail, and you never waste my time again." Kaiser smiled. "I'll do it in 4. The British had already designed the ship Kaiser needed. It was called the Ocean Class, a simple, ugly, utilitarian cargo vessel based on an old tramp steamer design from 1879. No curves, no elegance, just a flat-bottomed, slab-sided box with a bow, a stern and 5 cargo holds. Maximum carrying capacity, 10 800 deadweight tons. Cruising speed, 11 knots. Range, 17 Jerusalem miles. The British could build one every 8 months. They needed them in 8 weeks. Kaiser bought 155 acres of mudflat in Richmond, California, and started building a shipyard from nothing. He hired 10 Giuzunzeren workers. Most had never seen a ship up close. He hired housewives, grocery clerks, farmhands, and high school teachers. He ran 3 8-hour shifts, 7 days a week. He bought 50 1,000 tons of steel. He bought welding equipment from every supplier west of the Mississippi. He brought in arc welding instructors from every technical school in California, and he started building the SS Ocean Vanguard. The keel went down on September 14, 1941. The hull was welded, not riveted. Every seam fused with a continuous arc weld that was faster, stronger, and required less skill than driving hot rivets through overlapping plates. Kaiser divided the ship into 250 prefabricated sections, walls, floors, bulkheads, and deck panels that were welded together on the ground, lifted by crane, and welded into place. It was construction, not shipbuilding, the same techniques he'd used building dams. The Navy sent inspectors weekly. They measured weld penetration, tested seam strength, and waited for the whole thing to fall apart. It didn't. On January 15, 1942, the SS Ocean Vanguard slid into San Francisco Bay. Construction time, 123 days. Vickery sent a telegram the next morning. Contract approved. Build 60 ships. Deliver by December. Kaiser built 60 ships by June, but Kaiser wasn't celebrating. He was already calculating how to build them faster, because 60 ships was nowhere near enough. German U-boats sank 87 Allied vessels in March 1942 alone. The entire American shipbuilding industry, every private yard, every Navy facility, every coastal port from Maine to California, was producing 120 ships per month. The Germans were sinking 100. The math didn't work. The Allies were still losing. What none of them realized was that Kaiser wasn't just building ships. He was building a system to build ships, a factory, an assembly line. The same revolution Henry Ford had brought to automobiles. Kaiser was bringing to naval construction, and he was about to prove that the only limit on American production was imagination. Between March 1942 and August 1942, Kaiser opened 4 new shipyards in Richmond, California. Each yard had 7 building ways, 7 parallel construction lines running side by side. 28 ships under construction simultaneously. He hired 90 workers. He built entire neighborhoods for them: houses, schools, hospitals, and grocery stores. He paid them $1.20 per hour, nearly double the national average. He provided free childcare so women could work the night shift. He built the Richmond Shipyard Railway to bring workers from Oakland and San Francisco. He ran cafeterias that served 30,000 hot meals per day. And he kept cutting construction time. The first Liberty ship took 244 days. The 10th took 150 days. The 100th took 60 days. By June 1942, Kaiser's Richmond Yard No. 2 was launching 1 complete ship every 10 days. Bethlehem Steel, the largest shipbuilder in America, was still averaging 140 days per vessel. Then Kaiser met Joseph Thompson. Thompson was a 34-year-old shift supervisor from Yard No. 2, a former high school math teacher from Fresno who'd been hired as a welder trainer in January 1942. He had red hair, wireframe glasses, and a habit of writing equations on his clipboard during lunch breaks. He'd been timing every step of the construction process: crane lifts, weld passes, section installations, deck plating, and he noticed something nobody else saw. The bottleneck wasn't the welding, it was the waiting. Welders stood idle while cranes repositioned. Cranes waited while sections were measured. Measurement teams waited while the next prefabricated section arrived from the assembly area. Every step was efficient in isolation, but the sequence was chaos. There was no coordination, no rhythm, no flow. Thompson wrote a proposal, 15 pages, detailed schedules synchronized by the hour for every crew on every building way. Cranes moved in patterns. Sections arrived in sequence. Welding teams worked in rotation, so torches never went cold. He called it Continuous Production Assembly. He submitted it to his yard supervisor on June 18, 1942. The supervisor threw it away. Thompson submitted it again on June 25th. It was ignored. He submitted it a third time on July 2nd, directly to Henry Kaiser's office. He didn't expect a response. Kaiser was building 30 ships per month across 4 shipyards. He didn't have time to read proposals from shift supervisors. Kaiser called Thompson at home that night. "Can you implement this?" "Yes, sir." "Well, how long?" 2 weeks to retrain the crews, 4 weeks to test. You have 3 days. On July 8, 1942, Yard No. 2 started using Thompson's system. The first ship built under the new process was the SS Robert E. Peary. Keel laid, September 27, 1942, 8:00 a.m. Launch, September 31, 1942, 11:47 a.m. Total construction time, 4 days, 15 hours, 29 minutes. It was the fastest construction of a ship that size in human history. The previous record, set by Kaiser himself 3 weeks earlier, was 7 days. The Robert E. Peary wasn't a stunt, it was a proof. Every weld passed inspection. Every bulkhead met Maritime Commission standards. Every system functioned. On October 6, 1942, the Peary left San Francisco Bay carrying 10,000 tons of cargo bound for British forces in North Africa. It crossed the Pacific, rounded the Cape of Good Hope, and arrived in Alexandria, Egypt on November 23, 1942. 0 mechanical failures. 0 leaks. The crew reported the ship handled better than traditionally built vessels. German naval intelligence didn't believe the reports. A Kriegsmarine analysis from December 1942, captured after the war, stated, "American claims of ships built in 5 days are propaganda, physically impossible given known construction methods. Estimated actual construction time, 90-120 days. Allied deception operation to create false impression of industrial capacity." But it wasn't deception. By January 1943, Kaiser's Richmond yards were launching an average of 3 Liberty ships per day, 1 every 8 hours, 18 ships per week. The German U-boat campaign, which had nearly strangled Britain in 1942, suddenly couldn't keep pace. For every ship sunk, two more appeared. By March 1943, the Allies were gaining tonnage faster than the Germans could sink it. The Liberty ship wasn't elegant. It was slow, ugly, and uncomfortable. Sailors called them sea trucks. The engines were loud. The quarters were cramped. The riveted versions leaked, but they worked. They carried tanks, planes, locomotives, grain, coal, ammunition, and 2,000 trucks per ship. They sailed to Murmansk, Alexandria, Brisbane, and Liverpool. They delivered 75% of all military cargo shipped overseas during World War II. And they kept coming. Kaiser built 821 Liberty ships between 1942 and 1945. Bethlehem Steel built 384. The entire American emergency shipbuilding program produced 710 Liberty ships in 4 years. That's more cargo tonnage than the entire global merchant fleet at the start of the war. They delivered 18 million tons of supplies to Europe and 5 million tons to the Pacific. The total construction cost $2 billion, adjusted for inflation. That's $35 billion in 2024 dollars, less than the cost of 3 modern aircraft carriers. 200 Liberty ships were sunk by U-boats, mines, or aircraft. 31 broke in half in rough seas due to weld failures in early production vessels. The Maritime Commission redesigned the hull reinforcement in June 1943, and structural failures dropped to 0. The remaining 479 ships survived the war. But Kaiser received no official recognition. The Maritime Commission gave credit to American industrial capacity in press releases. The Navy refused to acknowledge that a man with no shipbuilding experience had revolutionized their entire construction doctrine. Admiral Vickery, who had tried to kill the program in 1940, wrote in his 1945 memoir, "The Liberty ship was a natural evolution of British emergency designs. Its success was due to the skill and dedication of American shipyard workers." Joseph Thomson's name appeared nowhere in official records. His continuous production system, which cut construction time by 70%, was classified as proprietary industrial process and sealed in Maritime Commission archives. He received no bonus, no promotion, and no public acknowledgement. He returned to teaching high school math in Fresno in 1946. After the war, Kaiser went back to building dams and highways. He founded Kaiser Permanente, the health insurance company, to provide medical care for his shipyard workers. He built automobiles, the Kaiser Frazer, that failed commercially and bankrupted his car company by 1955. He built the Hoover Dam bypass. He built highways across California. He died on August 24, 1967, at age 85, in Honolulu, Hawaii. His obituary in the New York Times mentioned the Liberty ships in the 6th paragraph, after his dams, his health insurance company, and his failed automobile venture. The Richmond shipyards were demolished in 1946. The land was sold to developers. A small museum opened in 1999 in one surviving warehouse. It displays photographs, a few rusted hull sections, and a plaque that reads, "Here, 90,000 Americans built 747 ships in 490 days." Joseph Thomson died in 1978 in Fresno, California. He was 70 years old. No newspaper ran an obituary. His family donated his papers to the Fresno County Historical Society. The collection includes his original 15-page proposal for continuous production assembly, annotated with Henry Kaiser's handwriting. Why didn't we think of this? Today, 187 Liberty ships still exist. 2 are operational museum ships. The rest were scrapped, sunk as target practice, or converted into floating storage. But for 4 years they were the logistical backbone of the Allied war effort. They proved that speed matters more than perfection, that innovation beats experience, that the impossible is just a timeline nobody's attempted yet. If this story moved you, hit that like button to help us share these forgotten stories with more people. Subscribe to this channel so you never miss another tale of courage and ingenuity from World War II. And drop a comment below. Tell us where you're watching from and whether you have a connection to the shipbuilding industry or the men and women who worked in these yards. These stories survive because people like you care enough to keep them alive. Thank you for watching. And remember, the next time someone tells you something is impossible, ask them if they've tried building it in 4 days. The woman who welded faster than any man But there's another story inside this story, one that Henry Kaiser never wanted to tell, and one that the Maritime Commission tried to bury in classified reports. December 3rd, 1942, 11:20 p.m., Richmond Shipyard No. 3, Building Way 5. The night shift was 40 minutes behind schedule on the SS Jeremiah O'Brien. A critical bulkhead seam, 17 feet of continuous weld along the engine room wall, had failed inspection twice. The metal was warping from heat stress. Every attempt to re-weld it made it worse. The shift supervisor was threatening to scrap the entire section and start over. That would cost them 8 hours, maybe 12. Wendy Munro was watching from the catwalk 20 feet above. She was 28 years old, 5'2", 110 pounds. She'd been a waitress at a truck stop diner in Bakersfield 6 months earlier. Now she was the fastest welder in Richmond Shipyard No. 3. And she knew exactly what was wrong with that seam. The problem wasn't the welder's technique, it was the sequence. They were welding continuously from port to starboard in one long pass. The metal was expanding unevenly, creating internal stress that twisted the plate. By the time they reached the end, the beginning had already warped. Wendy had seen the same problem 3 times in the past 2 weeks. She'd fixed it every time. But this wasn't her section. This wasn't her shift. And the supervisor down there, a man named Douglas Kern, had made it very clear that he didn't take advice from women. Wendy climbed down the ladder anyway. Kern was a 51-year-old former iron worker from Pittsburgh who'd been building bridges since 1915. He had hands like catcher's mitts and a voice that could cut through the roar of arc furnaces. When Wendy tapped his shoulder, he spun around with his welding hood still down. "I don't have time for questions, honey. Go back to your station. You're welding it wrong." Kern lifted his hood. His face was red, partly from the heat, partly from anger. "Excuse me? You're running a continuous bead. The metal can't dissipate heat fast enough. You need to weld in 3-foot sections, alternating port and starboard, letting each section cool for 90 seconds before the next pass." "I've been welding for 27 years. "Then you should know better." The other men on the crew stopped working. This kind of confrontation could get you fired. Women didn't talk to shift supervisors like that, especially not women who'd been hired off a diner floor 4 months ago. Kern stepped closer. He was 11 inches taller than Wendy. "You think you can do better?" "Yes." "Fine, you've got 30 minutes. Fail, and I'm writing you up for insubordination and you're off this ship. Succeed, and I'll buy you coffee." Wendy strapped on her welding hood, checked the amperage on the arc welder, and adjusted it down by 15%. Lower heat, more control. She marked the bulkhead seam in chalk, 3-foot sections numbered 1 through 6. Port side first, section 1, 3 minutes. Section 2 on the starboard side, 3 minutes. Back to port, section 3. She worked in a rhythm, letting the metal cool between passes, watching the color change from white-hot to cherry red before moving to the next section. The other welders stood in a semicircle, watching in silence. Kern checked his watch every 2 minutes. At minute 27, Wendy finished section 6, shut off her torch, lifted her hood, and stepped back. "Check it." Kern ran his hand along the seam, perfectly flat, no warping, no gaps. He pulled out an inspection gauge and measured the weld penetration at 6 points, all within tolerance. He called over the night shift inspector, a Maritime Commission engineer named Samuel Ortiz, who'd rejected the previous welds. Ortiz spent 5 minutes checking every inch with a flashlight and a magnifying loupe. "Pass." Kern looked at Wendy for a long moment, then he nodded. "Coffee tomorrow, 6 a.m., don't be late." What Kern didn't know was that Wendy Munro had been fixing bad welds for 2 months, not officially, not on any paperwork. But every night shift, she walked the shipyard looking for problems. Warped seams, failed inspections, sections that were about to be scrapped. She fixed them quietly, alone, without asking permission. By December 1942, she'd personally saved Kaiser's Richmond yards an estimated $47,000 in wasted materials and rework time. She learned to weld in 6 weeks, same as everyone else. But she'd learned something else before that. Heat distribution, thermal expansion, metal fatigue. Not from a textbook, she'd never finished high school. She learned it from watching engines overheat in the diner parking lot. Wendy had worked at the Gridiron Diner on Highway 99 in Bakersfield since she was 19. Graveyard shift, 10 p.m. to 6 a.m., serving truckers, farmhands, and oil field workers. She made $18 a week plus tips. The cook was a man named Eddie Navarro, who'd been a mechanic in the Civilian Conservation Corps before the Depression. When trucks broke down in the parking lot, which happened 3 or 4 times a week, Eddie would go outside with his toolbox and fix them for free. Wendy started watching. She asked questions. Eddie showed her how to diagnose a cracked engine block by listening to the cooling system, how to spot a warped cylinder head before it failed catastrophically, how heat moved through metal in predictable patterns, how you could prevent failure by understanding stress. "Metal wants to move," Eddie told her once, lying under a Ford flatbed at 2 a.m. "You can't stop it. You just gotta let it move where it won't hurt anything." In June 1942, Wendy saw a recruitment poster at the Bakersfield post office. Women needed for defense work, $1, 20 hour. Housing provided. Apply Richmond shipyards. She quit the diner that afternoon, took a Greyhound bus to Oakland, and reported to the Richmond hiring office the next morning. They asked if she had any experience with metalwork. She said, "I understand heat." They put her in welding school, 6 weeks, 8 hours a day, learning arc welding, acetylene cutting, blueprint reading, and steel fabrication. The instructor was a man named Harold Pitts, a former Navy machinist who'd trained 4 Zuozeran welders since January 1942. He had a rule. You pass inspection 3 times in a row, you graduate. Fail once, you start over. Wendy passed on her first try, all 3 times. Pitts pulled her aside after graduation. "You're the fastest learner I've seen, and the steadiest hands. I'm recommending you for critical seam work, engine rooms, bulkheads, watertight doors. It's the hardest welding on the ship. Most people wash out in a week. You interested?" "Yes, sir." She started on the night shift in Building Way 5, Richmond Yard No. 3 on August 12, 1942. Within 2 weeks, she was out producing welders with 6 months' experience. Within a month, she was training new hires. Within 2 months, shift supervisors were requesting her by name for difficult repairs, but she wasn't getting promoted. She wasn't getting raises, and her name never appeared on the production reports that Henry Kaiser reviewed every morning. The issue wasn't competence, it was policy. The Maritime Commission had agreed to hire women for shipyard work in March 1942, but only for non-critical roles. Welding was considered critical. The official position, stated in a memo from Admiral Vickery's office, was that women lack the upper body strength and temperament for sustained arc welding in combat vessel construction. Kaiser ignored the policy. He hired women anyway. By December 1942, 28% of Richmond's shipyard workers were female. But he couldn't officially promote them. He couldn't put their names in production reports, and he couldn't give them credit for innovations or repairs, because that would draw attention from the Maritime Commission and risk losing his contracts. So Wendy Munro welded in the shadows. She fixed what others couldn't. She trained men who would later be promoted over her, and she kept quiet, because $1, 20 an hour was more money than she'd ever made, and losing this job meant going back to the Gridiron Diner in Bakersfield. On January 15, 1943, Douglas Kern submitted a report to Henry Kaiser's office. It was titled, "Thermal Stress Reduction in Continuous Seam Welding, a New Technique." It described in technical detail the alternating section welding method that Wendy had shown him in December. The report estimated it would reduce weld failures by 40% and save the shipyards $200 per month in rework costs. Kaiser ordered it implemented across all 4 Richmond yards immediately. Douglas Kern's name was on the report. Wendy Munro's name appeared nowhere. The new technique worked exactly as promised. Weld failure rates dropped from 12% to 7% in the first month. By March 1943, it was standard procedure in every Liberty shipyard on the West Coast. Bethlehem Steel adopted it in April. The Maritime Commission included it in their revised welding manual in June. It saved an estimated 200 hours of rework time per ship, roughly 2 days per vessel. Kern got a promotion to senior shift supervisor, and a $200 bonus. Wendy got a handwritten note from Kaiser's office. "Thank you for your continued dedication to quality work." She kept welding, building Way 5, night shift, 11 hours a day, 6 days a week. She welded engine room bulkheads, fuel tank seams, watertight door frames, and ammunition storage compartments. She trained 42 new welders between January and August 1943. 17 of them were men who became shift supervisors within 6 months. In September 1943, Wendy requested a meeting with her yard supervisor. She wanted a promotion to shift lead, a position that would increase her pay to $1.45 per hour and put her in charge of a 12-person welding crew. She had 9 months of flawless work. She had the fastest production numbers in her building way. She had personally trained half the welders in yard number 3. The supervisor's name was Martin Greer. He reviewed her request for 30 seconds and handed it back. "I can't promote you." "Why not?" "Maritime commission policy. Critical supervisory roles require prior industrial experience. You worked in a diner. Douglas Kern worked in bridge construction. That's not shipbuilding. Kern has 27 years in structural metalwork. I'm faster than Kern. That's not the point." "Then what is the point?" Greer leaned back in his chair. "Look, you're a good welder, one of the best we have, but you're a woman. The men don't want to take orders from a woman. It creates problems, fights, complaints. I've got a shipyard to run. I can't deal with that kind of disruption." Wendy stood up. "I fixed the bulkhead seam that Kern couldn't fix. I created the technique that's now standard across every yard in Richmond. My name should be on that report." "Your name isn't on anything because you didn't submit anything. Kern submitted a report. You showed him a trick. That's not the same thing. It's my technique." "Prove it." She couldn't. There was no paperwork, no documentation, no witnesses willing to contradict Kern's report, just her word against a man with 27 years of experience and a promotion. Wendy walked out of Greer's office and went back to work. She kept welding until August 15, 1945, victory over Japan Day. The war was over. Within 2 weeks, Kaiser started shutting down the Richmond yards. Building Way 5 closed on September 1, 1945. Wendy's last shift was September 3rd. She'd welded on 47 Liberty ships. She'd trained 126 people. She'd created a technique that saved the shipbuilding program hundreds of thousands of dollars and cut production time by 2 days per vessel. Her final paycheck included a typewritten note. "Thank you for your service to the war effort. Best wishes in your future endeavors." She moved back to Bakersfield in October 1945. The Gridiron Diner had closed. She got a job as a seamstress in a dress shop on Chester Avenue. $14 a week, 40-hour weeks, no overtime. She married a Standard Oil field engineer named Robert Calloway in 1947. They had 2 daughters. She never told them she'd been a welder. She never mentioned the Liberty ships. When her husband asked about her time in Richmond, she said, "I worked in a factory during the war. Boring work, nothing special." Douglas Kern retired from Kaiser Industries in 1959 with a full pension and a commendation letter signed by Henry Kaiser himself. The letter praised his innovative contributions to emergency shipbuilding techniques. He died in 1967 in Richmond, California, at age 76. His obituary in the Oakland Tribune mentioned his role in developing revolutionary welding methods that helped win World War II. Wendy Monroe Calloway died on March 18, 1994, in Bakersfield, California. She was 79 years old. Her obituary in the Bakersfield Californian was 3 sentences long. Wendy Calloway, 79, died peacefully at home. She is survived by her daughters, Patricia Gomez and Linda Chen, and 5 grandchildren. Services will be private. In 2003, a graduate student at UC Berkeley named Sarah Matsumoto was researching the role of women in wartime shipbuilding. She found Wendy's name in a Richmond Yard No. 3 personnel file, a routine time card from January 1943 that listed her work hours and pay rate. On the back of the card, someone had written in pencil, "Best welder in the yard. Ask her about bulkheads." Matsumoto spent 2 years tracking down every document she could find: time cards, pay stubs, shift schedules, and inspection reports. She found 47 ships that Wendy had worked on. She found Douglas Kearns' 1943 report on thermal stress reduction, and she found a handwritten note in Henry Kaiser's personal papers dated January 20th, 1943. Kearns' welding technique came from the Monroe woman. Make sure she's taken care of, give her something. There's no record of what, if anything, Wendy received. Sarah Matsumoto published her findings in the Journal of Industrial History in 2006. The paper was titled Invisible Labor, Women Welders and the Liberty Ship Program, 1942-1945. Wendy Monroe was mentioned in 2 paragraphs. Matsumoto interviewed Wendy's daughters, who remembered their mother as quiet, practical, and never interested in talking about the war. She said it was just work. Patricia Gomez recalled, she said a lot of people did a lot of work, and nobody remembers most of them. She said that was fine. She said remembering the ships was more important than remembering the names. Today, there's a small plaque at the Rosie the Riveter National Historical Park in Richmond, California. It lists the names of 250 women who worked in the shipyards during World War II. Wendy Monroe's name is number 187. No details, no explanation, just a name on a wall. But if you look closely at the SS Jeremiah O'Brien, one of 2 operational Liberty ships still afloat, you can find her work. Engine room bulkhead, starboard side, 17-foot seam. Inspection stamp dated December 4, 1942. The stamp reads, Pass, So. Samuel Ortiz, night shift inspector. That seam is still holding, 82 years later. If this story moved you, hit that like button, subscribe to this channel, and drop a comment below telling us if you know a woman, your grandmother, your mother, your aunt, who worked in defense industries during World War II and never got credit for what she built. These names deserve to be remembered.